There are requirements for constructing a confidence interval, t-interval, for a population mean mu. The first condition or requirement is data comes from a random experiment. So a simple random sample is an example of this. Second requirement, the n needs to be less than or equal to 5% of your population. So this is your test for independence. And 3, needs to be normally distributed, or n needs to be greater than or equal to 30 because of the central limit theorem. This normally distributed also has to have no outliers. So let's get into the construction of a 1 minus alpha times 100% confidence interval about the population mean mu. For the calculator command, we're going to use number 11. Here we have the formal definitions to find the lower and upper bound without the calculator number 11. And again, you can take the point estimate minus margin of error to get the lower bound, and the point estimate plus the margin of error to get the upper bound. And here is the formal definition for margin of error, which is this portion. And the margin of error, you can find that by taking your upper bound minus your lower bound and then divide that whole thing by 2. You can use number 11 to find the confidence interval, which gives you upper and lower. You can subtract those and divide by 2 to get you the margin of error, if that's what the question is asking for. So let's look at the first example. The website fueleconomy.gov allows drivers to report the miles per gallon of their vehicle. The data shows the reported miles per gallon of 2011 Ford Focus automobiles for 16 different owners. Treat the sample as a simple random sample of all 2011 Ford Focus automobiles. Construct a 95% confidence interval for the mean miles per gallon of a 2011 Ford Focus. Interpret this result. So the first criteria was that it's random, which it was. Second, 5% of the population. This 16 is definitely less than 5% of the total Ford Focuses out there. And then normally distributed. So what we could do is look on our calculator sheet, number 11. First, it says put the data into list 1. So let's just do that right away. So I'm going to pause the video. I'm going to put everything into list 1 and then I'll resume the video. Now we have the list in list 1. Since we have 16, we do not know if it's normally distributed and if it does not have any outliers. So what we're going to do first is check for normality. So go to second y equals. Make sure select plot 1 is on. So you can see it is highlighted. It says select the last graph. Data list is L1. That's where we put our data. Hit graph. It looks like I have a line in there. So let's clear that out. So y equals clear. Go back to graph. Not seeing anything. So go to zoom, number 9. And that will get you your dots. Okay, now I'm seeing that this is pretty close to a straight line. What we're looking for is if we found the correlation for this, which we did not cover. This is a lesson that was not mandatory for me to cover for this class, but we can visually see that this is pretty close to linear. If the correlation is greater than a critical value, you will be given these on a test or quiz or homework. Then we know it's normally distributed. Okay. And when it forms pretty much a close straight line, we also know that's pretty close to normally distributed. Then to check for outliers, go to second y equals. want the plot on. Now we're clicking the fourth graph. You can see that there's dots. That means it's going to show us outliers. And hit graph, and you can see we have no dots. If you want to try your zoom, you can hit number 9. Again, there are no dots. These dots on the side just represent your y-axis. So that criteria is met, the third criteria. Now we can actually get into constructing the 95% confidence interval. So if we go back, now we're down here on C. So we're going to go to Stat, Tests, number 8. We have data already put in. If we did not have data, you go to Stats, and you should be given this information: your X-bar, standard deviation, N, and your confidence level. So for confidence level, it was 95%. You can type either 95 or 0.95. It will work. Calculate, and you can see our lower bound is 35.25 and 38.35. So let's type that up in here. We are 95% confident that the mean miles per gallon of all 2011 Ford Focus cars is between 35.25 and 38.35 miles per gallon. See how picking 16 Ford Focuses would be a lot simpler and easier to be able to conduct than sampling all Ford Focuses and then coming up with a number. In here, we only had to do 16 different cars, and we can say we're 95% confident that it is between 35 and 38 miles per gallon for all 2011 Ford Focuses. In the previous example, the critical value is T sub 0.025 is equal to 2.131 for 15 degrees of freedom, whereas Z sub 0.025 is going to be equal to 1.96. The T distribution gives a larger critical value, so the width of the interval is wider. This larger critical value using the student's T distribution is necessary to account for the increased variability due to using S as an estimate of sigma. When constructing 95% confidence intervals for the mean, when the parent population is skewed right and the sample size is small, the proportion of intervals that include the population mean is below 95%. So let's draw skewed right. And in green, I'm going to draw a normal distribution. So here, this is about 95%, right? So we're constructing the 95% confidence interval for the mean. The parent population is skewed right in blue, and the sample size is small. The proportion of intervals that include the sample mean is going to be below 95% because there's more in this tail. You can see this area, there's more in the tail, thus making it below 95% because we want it within this 95, not on the outside. And then when constructing 95% confidence intervals for the mean when the parent population is skewed right and the sample size is small, the proportion of intervals that include the population mean approaches what as the sample size n increases. So kind of using your law of large numbers, as n increases, what's going to be in this proportion, or sorry, interval? 0.95. It's going to approach this as n increases. If the requirements to compute a t-interval are not met, one option is to use resampling methods such as bootstrapping. And bootstrapping is covered in 9.4, and we do not cover that section in this course. But know that it is out there.